things, you guys have actually done pattern recognition before. You've done that. Yeah, you've been doing it forever. You know, apple, orange, what's next? Orange. There you go. So, that's okay. Thank you. Good to see you. As you go through these things, what we're going to start to work with here today is we're going to start to work with them as sequences and series, show the difference between the two, and how you can write out what's called the explicit rule. We're going to work with explicit rules today for kind of a generic scenario. Over Wednesday and Thursday, we're going to start talking about arithmetic and geometric sequences and series. And then on Friday, we'll start talking about what's called the recursive rule. After we get through that one, we'll tie it all back together on Monday. That's why I figure we'll be done with this chapter, unit, whatever you want to call it, by Tuesday. And we'll start the next one then on Wednesday. So, sequences and series. When you look at these two sequences, you've got 3, 6, 9, 12, 15. And then 3, 6, 9, 12, 15, dot, dot, dot. Thank you, sir. What was it? Same thing. Okay, cool. Thank you. What does a dot, dot, dot represent in math? Continuous. What do we call a continuous in math then?
Infinity.
Infinite. It's infinite. Infinity. So this thing, it just goes on infinitely. Okay? Yeah. Now, when you're dealing with a sequence, the numbers in the sequence, well, you've got 5 of them. Do you agree? Those numbers within the sequence are called terms. 1, 2, 3, 4, 5. These guys are all called terms. You've got the first term, second, third, fourth, and fifth. First term gives you 3, 6, 9, 12, and 15. What I want you to start thinking about with sequences is that you've got your first term generates something. Second term generates something. It's domain and range. X and Y, very good. Yeah. These are domain and range. Do you guys remember the difference between domain and range?
Range is like Y's, domain is like X's.
Yep. What comes first in the alphabet, X or Y? X. Yes. What comes first in the alphabet, domain or range? Domain. So that's how you remember that. Domain goes with your X value, range goes with the Y. You remember that? We didn't switch. Oh. So, wait, what?
I'm letting you go.
No, go ahead.
No, because I need to hear the rest.
No, go on.
No, but like I'm confused what domain and range has to do with it. Like, so the domain is the 1,
Yep.
and then range is the 3.
Yep. This generates that. It's like a function. First term generates the range. Your domain generates the range.
Figured out the formula.
And you've already figured out what was it?
X times the Y, or no, wait, Y times X. No, I had it right, and then you introduced X and Y.
It's 3x. The sequence here is just
I messed up when
3x.
you introduced X and Y. I had it. It's 3x.
Now, the way that we're going to write these out,
I had it right.
your book tends to write it out. Hold on a second. Your book tends to write it out in terms of n. It's not a big deal. You see function notation, you'll see a sub n. We're going to write it as the nth term, a sub n. The n is a little bit lower than the a. It's called a subscript. Okay? So if I want to write out the rule in terms of n, the nth rule, I would say it's a sub n equals 3n. N is my first term, bless you, 3 times 1, 3 times 2, 3 times 3, and so on. That's how it generates.
So the A sub n is the sequence, or like?
Yeah, it's kind of like the rule for that sequence. That's the generic rule.
Okay.
Yeah.
Be
That would be an and. Then I'd be looking for some word after it that starts with a vowel. That was an excellent question.
You just said that was an excellent question.
No. Now, when we start to write these things out in terms of the first sets of terms within a sequence, what that means is that we're always going to start with the first term. So you're starting with your n value being equal to 1. So I'd say, well, it's A sub 1 would be 2 times 1 plus 3. A sub 2, 2 times 2 plus 3. All the way down for, they want 6 of them. Now what's nice is that, granted, the math here is very easy. You could go through and probably pop those out in your head with nothing. 5, 7, and so on and so on. Okay? But what if I told you there was an easier way? What is it? Take your calculator out. Yeah. It slices, it dices, it Julienne scribes. Yes?
What are we supposed to be writing down?
I want to show you how you can use, instead of writing out all these terms and doing it all by hand.
Yeah, but like, with the stuff you're writing, what should we?
Oh, I'm going to show you something here. You probably don't need to write much of it. What I'm doing, instead of writing all of this out to figure out the first 6 terms in a sequence, that's normally how you would have gone about doing it, just plug and chug, if you will. I'm going to show you an easier way to do it with the calculator. You never heard that?
See, that n is as big as the 2 and right next to it.
Here's what I want you to do. I want you to go to the y equals button. Guys, I want you to go to the y equals on your calculator. And I'd like you to go ahead and type in the equation, 2x plus 3. Now, your calculators, the x value for your variable is right here. It's next to the alpha button. The alpha button is the green one. And then this plus 3. The x is next to the alpha button, next to the green one. Now, is it okay that this is in terms of n and this is in x?
Yes.
It means the same thing. It's a variable. Okay? Now,
Same scriptures number.
we don't need about it. We're not worried about it. Top left. Second graph. And then you get a table. Okay? Second graph. Now, what I want you to notice,
I don't know what that is.
top right. What I want you guys to notice is that look at my graph, look at my table. My table starts at 1. I guarantee most of yours didn't start at 1. Okay. You can, if you're starting at 0, you just scroll down, you can get to it without a problem. Now, what I did right away, since I know that I'm working with sequences in series, I knew that I'm looking at the first 6 terms, so I knew I was going to have to deal with my first term being 1. And this is going to be kind of like a love-hate relationship with your calculator. You're going to learn how to use it as things come up. You might not pick up on it right off the bat. Here's what I want to show you today is how do you change your table so that you start at 1. Very, very easy to do. I want you to press second window.
Oh, it's a wait.
532.
I want you to start your table at 1. Change it to 1. Okay. Change that to 1 and go back to your table.
Second table.
Oh, that's fancy.
I'm at 1.
And then you go back to 1.
They're changing from the absent. You don't
Everyone changed their table?
Yes.
Okay. Yeah. What's that? Is it second window? Hit second window. Go right back to second graph. Here we are. That's how you switch back and forth to your tables. So, what happens a lot of times, I think sometimes in chemistry people use the tables a lot for whatever, chemistry things. Now, what I want you to do is I want you to type in your calculator in the y equals this equation. I want you to type this one in. And I want you to list out the first 6 terms. Now, let me ask you this. What button on this calculator allows you to use exponents? The little caret thing, correct. Yes, sir.
Wait, no, it didn't work. Oh, wait, yeah, it did.
Clear.
I remember what that was supposed to.
Did you go down to the nurse?
Yeah, they gave me cream.
Yeah, if you want to wash your hands, it's fine. It's around the door. Do you know the bathrooms over here?
Yeah.
Okay.
So, Mr. Martinez, it's
It says error.
If you're getting error, that means you're doing something wrong.
I got 1, -2,
Nope.
16, -32.
Wait, what about that?
What'd you do? Oh, you don't want to see blood.
I got one.
I got a 6 and a 8.
No.
What? I did do it.
In our wife, and then put that for each.
I got it. Just for elbow. Oh, he's putting parentheses.
Yep. You gotta put it exactly there. Now, hey guys, when you see stuff like this, and this is kind of the whole idea. I wanted a lot of you guys to screw this up because a lot of you guys probably did, which is fine. When you're working with exponents, when you're working with the exponents, and you have negative values that have stuff with parentheses around them, you want to be as specific as what you are reading. You're going to type it in exactly the way that it's written. Parentheses, -2, close it to the x minus 1. You type it in exactly the way you see it. And then you go to your table. And those are your first 6 terms.
I said X.
Did you use -2 or -2?
I use negative.
It's like 2. But you have
No.
Second table. Oh, I got 1, -2, 4, -8.
You get it? Don't worry about that.
Doesn't tell you the kind of person. Sure, you hurt yourself. Might have broken your finger. You can do it. That's with all the snow. But
You have to the -1
negative.
Remember, guys, there is a difference between these two buttons.
Negative.
This one is your negative,
And then
this one is your subtract.
So is it supposed to be negative?
It's x minus 1. It's x minus 1. If it was a negative x, we'd say negative x. Okay? So now,
Hey, we're talking too much, guys.
whenever you guys are ready, okay? You don't have to throw the batteries away and recycle last time.
See?
Oh my
See?
God.
Yes.
That's why you sit down and stop talking. You ready now? When you're writing rules for these, we're going to write out in terms of n what is going on. We need to identify the pattern and write out what's happening. When this happens, the easiest thing to do to generate, just like we were doing earlier with 3 times n, or whatever the other ones were, the easiest thing to do is to fall back into the idea of domain and range. First term is -1/3, second term is 1/9, third term is -127, fourth term is 1/81, and so on and so forth. So when I see that, and I need to write out the rule, what I like to do is write it in terms of x and y. I know that my first term is -1/3. My second term is 1/9. And I need to figure out, how do I generate those numbers given that information? Yes, sir?
You square it.
Correct. Very good. What's happening here, and you're on the right, to go from negative 1/3 to 1/9, isn't that negative 1/3 squared? Because what's a negative times a negative? If I take a negative times a negative times a negative, what do you get?
Negative.
And then if I go negative, 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 I get? See, that's how you're able to alternate your signs sometimes. By changing your exponent between its, whether it's odd or even. That allows you to get positive and negative values. So you were starting out with, your first term was negative 1/3. So wouldn't that be the same idea as saying a sub n equals negative 1/3 to the nth power? Put that in parentheses so we don't mess that up. Because then if I square it, I get 1/9. 3 cubed is 27. 3 to the 4th is 81. That's how you're able to go into these things. Now, it's going to take you a little bit of time to try to find some of these patterns. But what's nice is that to test what your pattern idea is, you got a great little tool here by pressing y equals. If you put in y equals what your guess is, and go to your table, it'll tell you if you're right or wrong by just matching up your numbers. Does that make sense? It's a nice, easy way to check yourself. Am I on the right track? I'm not going to lie to you. A couple of these, especially just in this first section, are awful. It really makes you stop to think about what is going on here. So take a minute and see if you can get the next one. 2, 6, 12, 20. Yes, sir?
So it's basically the an, like you just want to n,
Yeah.
that n equals x plus
Yeah, yeah. Your book writes it in terms of n, like what is the nth term, what's the nth rule. I always bring it back to domain and range. I like to do that, so if you want to think of it that way. All right, or you can think of it in terms of function notation type style as well. So what I want you to do is try to work with, let me put this on the second. This 2, 6, 12, 20. Try to see if you can come up with it.
Do we have to use the calculator for?
You don't have to use calculator, but I'm just saying, a lot of times it's easier, so that way you can figure out if your rule is correct or not. The calculator allows you to try to double check it. What do you think?
Is it n plus 2?
No. If it was n plus 2, that means if I'm starting at my first term, the 1 plus 2, which would give me 3.
Oh no, that's not what I'm like the number it adds always gets like 2 more, like at first it's from 2 to 6 it skips 4, then it from 6 to 12 it skips 6,
But you have
and
to
then
write
from
that-
12 to 20 it's
But you have to write in terms of your first term generates 2, your second value generates 6, your third value generates 12. See how it's different there? You're finding out the pattern because I bet you can tell me what the next number is.
yeah,
What is it?
30.
Correct. What's after that?
42.
Very good. So you can get the pattern. You can get the pattern.
How do you turn that in terms of n then?
That's the trick. That's what's different, that you have to start to think a little bit differently. And that's where this section is tough. It makes you think differently. But the calculator is going to help you test some of them. But Clay, you had your hand up a second ago.
That's what I was going to ask.
Oh, okay. Let me think they have. What is it?
We got n times n plus 1.
Perfect. Perfect. What about this? Same thing, right? What's 1 squared?
1, 1.
What's 1 plus 1?
2,
What's 2 squared?
4,
What's 2 plus 4?
6,
What's 3 squared?
9,
What's 3 plus 9?
12,
What's 4 squared?
16.
What's 16 and 4? There we go.
Take the right a.
That's weird.
So your pattern here, the rule for this one would be either one of these. Either one of these works out just fine. And yes, it's going to frustrate you, it's going to make you mad. Because it takes a little bit of time to get back to try to figure out what in the world is going on. Was it easier for you guys when you figured it out, when you wrote it out like a table? It's sometimes a lot easier to write it out in terms of domain and range. Do you have to? No. And you're right, it's tough to go, you can figure out the next terms all the time. And that's what's different. A lot of times you'll see that in like in an ACT, it'll ask you what are the next three numbers in the sequence. You'll figure that out real quick. But if they ask you to write it out in terms of n, that's where the trick comes in. Okay? But that's also where you can use your calculator to help solve those style problems. Yes, sir?
Why didn't you know the A6 it's just like X? Oh, like,
It's just the way they write it. It's mathematical etiquette. Yeah, this is just writing this in generic form of an equation. Number in a sequence, if it's the first term, you substitute in 1 for n. It's basically kind of like function notation. You guys have seen stuff where it says f of x equals x plus 2.
Yeah.
What's f of 3? You get 3 plus 2. It's along the same lines as that. This will, you look like you were very frustrated for a minute there. What's wrong?
Oh,
You're lying. What do you got?
So, I'm still confused on what n is exactly. Like, is it just
Number in the sequence. N stands for the specific term in the sequence. If it's the third term, n would be 3. If it's the fifth term,
okay,
it's 5.
I got it. Okay.
What do you got?
where's the fraction again?
Oh, fraction key. Good question. Fraction key. When you want to write out a fraction in these things, it's alpha y equals. And you get the same idea of what it would look like when you're working with those multi-view calculators that you used last year. You get the same fraction bar looking thing. Alpha y equals gets you the fraction bar. Okay? You okay on that? All right. So what's the difference between a sequence and a series? It should be blatantly obvious.
There is
I like to buy
That's
box
it.
sign of some
No, I'm just looking at what's the difference between a sequence and a series.
three additions.
The only difference between a sequence and a series is this. When you're in a series, you're adding up all the values that's in the sequence. Not necessarily. I know where you're going with that, though. Now, in this case, if I'm looking at this finite sequence, finite series, infinite sequence, infinite series, that just means the infinite sequence continues on and on forever. An infinite series also continues on forever. Finite just means it ends. Yes, ma'am?
Why do you add them? Like, what would you need a series for?
If you want to add up a whole bunch of things. So if you want to add up the sums of something.
What about
Oh.
infinite series? Like, you
There's
could
a
never
way-
get an outcome.
Yeah, you can. That's in section 11.4, and we might get to that. I don't know. We don't need to, but I can show you guys. It's really easy. There is a way to add up.
Whatever answer you get wouldn't
It
there
converges.
always be more?
It converges to a specific value. There's a reason for that, and I'll show you guys that later on. I will show you. It's a very easy formula. It's very, very easy. There's one caveat to it, and I'll explain it when we get to it.
Yeah, but logically, if it's infinite, it's never supposed
There
to
is a
end.
way. Look in section 11.4 in your book, and it shows you how to do it. There's a way to do it, and there's reasons that it works, and I'm not doing that today.
Okay.
All right. Now, what happens here is, could we figure out what it is for the rule for this sequence here? 3, 6, 9, 12, 15.
Yes.
What's the rule? 3n? Are we okay with that? The rule here would just be, because this is our first term, second, and so this would be a sub n would equal 3n. You're okay on that?
Yes.
Now, when I want to add up a whole bunch of things that's in a sequence, this is where we introduce you guys to what's called summation notation, sigma. Big E. Big E is the Greek letter sigma. It stands for add. And you're going to add a whole bunch of junk. Okay? When you're adding a whole bunch of stuff, you have to know which term are you starting with and which term are you ending with. Well, in this sequence, in this series, we're starting with the first term, which is 3. So I say n equals 1, because I'm starting at the first term. How many numbers are in that sequence? Or excuse me, in that series? There's 5 of them. So I'm starting at my first term. I'm going to add up 5 of them. And what am I adding up? What rule am I adding? I'm adding 3n. That stands for 3 plus 6 plus 9 plus 12 plus 15. That's how you convert things into what's called summation notation. Now, yes, sir?
How would that help?
It doesn't really help that much when you're doing adding 5 numbers together, but it helps out a lot if there's 25 of them, right? Because there's a button for it. Oh. So if I'm going to work with this one, I want to add 5 of them together. You guys can probably add that up in your head real quick. It's not that bad. What I want to do is show you how you can do this in your calculator. Alpha window. Does everybody see option number 2 is sigma notation?
Yeah.
Go to number 2. And hit enter. And then you get that right on your screen. You get that right there. So now it's just a matter of putting in your variable. Now, I'm writing this in terms of n, but does it really matter to the calculator if it's an x or an n? Nope. I put in x. It automatically jumps over. What term am I starting with? 1. It doesn't automatically go up to the top one, so you just hit the up arrow. And how many of them are we adding up? 5 of them. And then all I do in my parentheses here is I type in exactly the explicit formula, 3x. And then I hit enter. I get 45. Sigma notation is great, especially for the button if you had to add up 25 of them. Okay? Kind of makes sense on how to do that?
Yeah.
Okay. Now, what's different then when you want to write it out in terms of an infinite series? Do you still start at your first term?
Yeah.
Do we still have 3n as our explicit rule? Okay. So the difference here then becomes the following. I still start with the sigma. I'm starting with n equals 1. I have 3n for my rule, but what am I adding up to? Infinity. I'm adding through infinity. And I leave it at that. Like I said, there's no infinity button on your calculator. There isn't a way to do it on your calculator. There's a specific formula for certain types of series in section 11.4 that we can show you, but I'm not bothering with it today. Okay? I'm not going to bother with it today. That's how you write that out. If you notice, the trickiest thing for this really winds up being, can you write the rule? And that's where it becomes tough. And to be honest with you, section 11.1 is harder than 11.2 and 11.3 because it could be anything for the rule. At least in 11.2 and 11.3, there's a specific algebraic way to solve it for arithmetic or for geometric. It's much easier. Okay? What is that purple one? The purple one is for the infinite series. How you write it out. The only thing that changes is that the top number is infinity. That's it. That's the only thing that changes. So what I'd like you to do here is I'd like you to write both of these two series out in terms of sigma notation. I'd like you to write it out with the sigma in it. So when you start with those, remember you're always going to start with that. What's always going to be your first number in the sequence? 1. So we start at n equals 1 or x equals 1. It's okay if you write it either way. I'll write it as x this time. And then you have to figure out your rule. Because that first part A there, does it tell you how many terms are in that sequence? But could you figure it out? How?
How many fives are
Yeah, you guys were able to figure out that it's going up by 5s, right? 5 times 1, 5 times 2, 5 times 3 all the way. Well, 5 times what is 100? 20. So what goes on the top? 20. And what's my rule for the inside? 5x, or 5n if you wrote it in terms of n. If you type that in your calculator, what did you guys get? Very good. You didn't say you had to, but if you type it in, you should get 1,050. Hopefully. Sigma was alpha window. the other one? The other one's an infinite one. Do you guys agree on that?
Yeah.
Okay. The other one's infinite, so I know I'm going to start it out, my sigma, n equals 1 through infinity. But now I got to figure out how in the world am I going to generate those fractions? You don't have to put it in your calculator. Remember, we're not solving for what this is going to equal. I need to figure out what the rule is going to be here. We got Mr. Federici.
N divided by n plus 1.
Very good work, sir. N over n plus 1. How? Take a look. First term, your first term is 1 over 2. 1 over 1 plus 1. 2 over 2 plus 1. 3 over 3 plus 1. 4 over 4 plus 1. See that? And you're right. Some of you guys will pick up on it right away. Some of you guys will go stare at it for a while, hit your head over with a brick, go back to it and go, oh yeah, I remember that.
It's 10.
Yeah. It takes time. Like I've said, a lot of times students tend to pick up on these things easier if when you're looking at these, especially to start out with. If you're looking at these to start with, if you know your first term is 1 over 2, your second term is 2 over 3, your third term is 3 over 4. Sometimes it's easier to look at it in terms of x and y. How you go from here to here. Okay? A lot of times people see this style of problem when it's written vertically. It's just another way of looking at it. Okay? It just takes a little bit of time to go back to this. You've really never done this before. And it's going to take a little bit of time on a few of these. Okay? So don't get too frustrated. It's just math. Yes, ma'am?
So these are looking more at like the relationship between the x and y than the y's going forward.
If you can relate it in terms of x's to y, how you generate first term to get you this, second term gets you that, it's sometimes easier for people to pick up on it. Yeah.
Are all the problems going to be in like in order, or are some of them going to be jumbled up in order?
Oh, they'll all go right in order. They'll all go right in order, and I'll give you one hint on one of them that's just awful. I always forget that I forgot that I had it on the assignment. Now, we've already talked about this, this, and this. You don't need to put those in the calculator because it takes too long. But don't write this down because this book is old. Okay? This book is old. And like I said before, there were ways of, you guys remember special products in factoring? You know, a plus b, a minus b is a squared minus b squared, things like that.
No, like the difference of squares.
Difference of squares, you know, x squared minus 4 is x plus 2, x minus 2, things like that. Those are short pattern shortcuts, okay? Well, way back in the day before they had the alpha window button on the calculators, you actually had to memorize out some of these special patterns. There's no way that you need to know this anymore. I just want to show you where this is, you know, way back in the day. If it was I squared, you know, you had to memorize, oh, that's just x times x plus 1 times x plus 2, or whatever, all over 6. It's pointless. Nowadays, you just press a button. There's no reason for you ever to do any of this, crank this out by hand. There's a button on your calculator that you have to remember how to type it in correctly. Yes, sir?
Doesn't I have to do something with like square roots and stuff?
The I is an imaginary number. For some reason, the book goes back and forth between I being just a variable or I being an imaginary number. I don't like that. I like to just use I in terms of just an imaginary number. So I'm not going to ever make you memorize any of that junk because it's stupid. It's not worth it. Yes, sir?
What do you mean by imaginary number?
What's the square root of negative 4? Nope. Nope. Because remember, the square root is what are two numbers that you multiply together that are exactly the same to give you that product.
So the square root of a negative is not possible.
Correct. So that's why we have to come up with the imaginary number. When things don't work, you make something up. That's how math was invented. there's a little hint there for number 23. I always forget to tell people about this hint. The sequence that they give you in number 23 is really weird. You're not going to get a singular equation that works for all the numbers, whether the number in the term is 1, 2, 3, 4, 5. There's 5 numbers in the sequence. There's nothing there that'll work for both the odd number, 1, 3, and 5, and the even number 2 and 4. So there's actually 2 different equations depending upon if the number of the sequence is even or odd. I always forget to give people that hint. So if you can't figure out 23, it's not the end of the world. I always beat my head against that one too. Okay? Yeah, 17 to 29. All these things will be odds. I originally thought about starting at 9, but what's the point if you can do 4 of them, you can do 7 of them. So, questions? Do tomorrow. It's rare that I do the homework quiz. I will do those.